Alright, so I'm basically just rebuilding this circuit. This is a circuit I put up a long time ago. Well, I don't know, maybe it wasn't that long ago, but this is not like some circuit that I came up with for one. I've been over it many times before, but this is basically based off of a Tifatronic circuit, which was based off a Scory circuit. These are just two creators who had come up with some pretty cool circuits, and I just kind of made some slight modifications and was just tinkering with them, and I ended up with a build that I thought was pretty awesome. So I basically just drew exactly how that build was as it was at the time. So some of this might not make a whole lot of sense, but I just drew what I had, right, and it worked. So I've actually rebuilt this a couple times. Sometimes I'll kind of forget, like, man, how does this thing work again? And I'll just kind of build it based on this, just using it as a general guideline, right? But one thing I would always recommend to do is just, start off omitting all of this interrupter portion, right? Like you're looking for the base push pull circuit here, your switches, your coil, and you're not worrying about pulling the gates low or anything like that using this extra switch. And you've only got this voltage divider here, this pot, and this is how I used to do them. So it's just going to run continuous wave, but it's just an easy way to test it out if it's working, right? So rather than run this to a 12 volt reference off of a regulator or something, I'm just going to feed it main supply, so 12 to 30 volts, let's just say. For testing, I'd probably run it closer to 12 to 15 or something, right? And then I would just throw this pot on to get it started and just reference it off the main input, right? So again, the problem there is, you don't want to be ramping up your input voltage way up and down without adjusting that. It's more like you set a particular input voltage, then you ramp that up until you get feedback. But that's more or less what I would do. And once I saw that I was getting oscillation, at that point, it's just a simple thing of like, all right, well, I'm just going to interrupt it now, right? I'm just going to pull the gates low to interrupt it. So really, this circuit right here is so simple, it's crazy. And, I always make it more or less about the same. Got a few over here I was just messing with, real old one. This one's pretty cool. I stole the coil off that one for some testing. That's one that was actually works really good. This one right here works so good. I've only run it a couple times for some reason. I need to play some more with it. And then here's just another circuit I just threw together. Again, I'm using that coil just for testing, so that's why I rewound the other one. All right, so with this circuit, I actually found this little 1-1 pulse transformer, so I'm just going to use that. And it pretty much works the same as the other one that I had. It's just I'm not having to wind one, right? So again, a lot of times I'll say, like, yeah, just use one of these little 1-1 deals that you might find in like a filter on a some board already, right? And you don't wind one. But it's not like those are special or anything. It's just they seem to work fine, right? So likewise, this little guy seems to work fine. And I guess essentially the Zeners are what may be really doing the work on the gates. And again, this is just another deal. I think I might have actually wound this one, but I just wound a bunch of turns and cut it evenly down the middle to form a neutral point over there, which is the plus N. So again, I'm just going to run this guy. So again, this is just I played with different primary impedances basically just to kind of see what I wanted, and then just playing with the coupling a little bit. So it just it likes being a little higher up. The coupling is, I guess, is fairly low, but let's just say I move it up to like right about there, then it seems to like that. So let's just say I'll leave it right there. If I move it up any higher, then it just doesn't prefer it as much. I don't get as high of a voltage. But let's just say right now, here goes the little gate bias. So it's at 20 volts. I guess it's kind of going a little bit. And I'm just going to turn this up till I get output. Alright. So let me put it at like 24 volts. Nothing crazy. Actually, let me put it down to like 15 or something and do. See, there's continuous wave, right? So it's pulling quite a bit. If I add another turn or something like that, then it'll probably run that fine. But this battery is not gonna put out enough juice to really run it like that. But when I try to pull arcs, it'll pull them up to the point where this battery supply, it's not dropping too much, but it's probably not going to be able to push more than maybe 8 amps for a very short period. But just this particular coupling doesn't want to pull it down too much. So if I turn it up a little bit, right there, just kind of barely wants to sort of maintain that. Alright, so that'd be kind of one thing that the 250s might be good for. But really just kind of, not worrying too much about the voltage peaks they might be seeing. So actually, hold on a second. Let me see. Get this primary kind of chilling like that, and run it like that. So I'm just gonna do like 30 volts. That's the highest I can go with it. 31. Cut the lights down a little bit. There's actually, I don't know if you can see it's messing with my monitor in the background. It's cutting my monitor on and off right now. I'm not sure if that's because of this ground is so close or what, but it's probably a combination of that field. So I'm not going to run it all the way up at 30. So again, I guess in the past when I've used 250s, I've only had one setup, which is I got laying around here somewhere that I kind of like using these 250s. But I remember I took a whole lot of time trying to tune it so that I could get pretty good output, where it had much better output than this, and I could pump it to maybe like 50 volts. this is the type of setup where I just didn't really think it was worth it. I would much rather use, something like IRF 3205s, because I've just always found it much easier to tune and get a decent output from a coil of about this size. So this is a 36 gauge. I think this ends up being, with this size of a top load, somewhere around 750 kilohertz, something like that, right? So it's got a good amount of turns on it. And, you're probably better off maybe with half the turns, right? So I probably could have just only wound half of it, but just went ahead and did that just because, I thought it was a decent size and I had a piece of acrylic pipe, right? So basically, if I was to play around with this circuit a little bit, yeah, I could probably play with the drain capacitance a little bit. Then based on that, it might not run so well how this is set up now. Maybe I could play around with some caps on the primary circuit. Maybe that'll help that as well, combined with, playing around with the primary impedance, the coupling, top load, all that stuff, right? I could probably get it to a point where maybe it's a little better, or, maybe I could fine tune some primary cap values so where maybe it's a little better, right? But I'd say something about like that. It's going to be pretty close to that with this exact setup, no matter what I do, within reason. So something like that is what I would expect. And that's typically what I get when I throw these 250s on and build a circuit just like this, right? So this is like expected for me, right? And yeah, it's about right, to where, you play with a few things, get some pretty good continuous wave if you want, pull some hot arcs. You might be able to get the tuning to the point where when you're pulling hot arcs, it's really pulling a good amount of juice, and it's like a whole lot of power in them. Or maybe like you might be able to get it to a point where the arcs are a little bit nicer, and they get a little bit longer, right? But again, I've always just kind of just went right back to the 55 or 100 volt FETs, this little small one, something with a lower on resistance. And, which is basically what I did. So I just built another one of these circuits using some 3205s that I got. And I'm just going to take this same coil and use that, right? So with this circuit, I just got it disconnected from the coil. And you can see sort of the way it's laid out is just, I'm going to I've got one side of this little primary side over on a little Wago. So I'm just going to run the bottom of my secondary into that. Plug my primary into here, and I'm just leaving this other end of the primary for me to make a like a mains ground connect, whatever ground connection I've got, I can make there. So these are 10 nanofarad caps that I've got on the drains, just with this particular one. All right, so I don't have like tons of values or tons of them laying around, so typically I'm just like grabbing what I might have or have pulled from somewhere. Other ones I've used like 6.8. Some of them, a lot of these I'll just throw 100 nanofarads on, right? Coupled with maybe like another 100 nanofarad in series with the primary, and that's basically how I run them. It's basically the same deal with a TL494. I actually just built these on separate boards, but I decided to just kind of band-aid it together temporarily. Yeah, it's pretty much always the same deal, right? It's probably like 3 microfarad filtering right there on the rails. But yeah, let's say if I wanted to, I could probably swap these out with IRF 3205s as well, and only running it like 30 volts max, and I'd probably be fine, and it would probably run better on that same coil. But if I wanted to kind of play around with this circuit and leave it as is, then yeah, I could probably get it to the point where I don't really need to worry too much about the spikes, so long as they don't go over like 250, maybe something like that. For too long, it will be fine. And it's not like I gotta watch them. Whereas with the 55 volt FETs, obviously, you got to be a little more careful. It's like there's a point in the low voltage DC input range where you're creeping on too much now, and you're gonna blow them up. So, like I've always decided, okay, keep it 30 volts or less and try to get the best tuning from there. It's usually like good enough for me, right? So yeah, that's this guy, and the next guy is pretty much the same. All right, so now I got this one, which again is pretty much the same. It's just laid out a little differently. Still got the same 3-pot, same general circuit, TL494. Just got a sort of a big cap right here on the input. And then I've got my little terminal blocks here to put my FETs in. So those are the IRF 3205s, just random ones I got off Amazon. I got 4.7 nanofarad caps on the drains, just some random WEMAs that I found laying around and all my junk that I got scattered all over the place. Right. So yeah, I'm running a bunch of wires around, blah blah blah. But other than that, it's it's not that complex as far as the wiring. But you can see how I'm doing this one. Same thing. Got just a connection running off for my primary. Along with it, I got a 3 in 3 out connector, along with the bottom of the secondary. So bottom of the secondary, I'll run right here, 2 primary wires. And I've got that one going through. This is 100 nanofarad, just another little random capacitor film cap. And again, I'm using this guy that I was first using on the other circuit, because I don't have to wind another one. Kind of looks ugly, it's too big. Maybe I will wind another one day, but whatever, it works. So this is going to be the one I'm using, where again you can see it's pretty much the same thing. Got driver power and main input power there that I'm just momentarily tied together, and that's just how I'm feeding it, right? There goes my connection to ground, whatever it's going to be. Alright, so now with this coil on the circuit, I've got just sort of a random cap here, but I also know this general coupling of this primary and this secondary seems to be, alright for feedback. It's strumming the strings in a way where I seem to get good resonant feedback, right? So, do the same thing. With this one, I'm going to run it 15 volts. There you go. That seems pretty good. So I'm basically gonna cut this up. I've got it running about like that right now. So I'm gonna cut the gate voltage up till I see output. And I actually saw output first, and that little guy, I saw the needle on here jump up just a tiny bit, but I saw this actually outputting first. And then I was also able to draw the little arcs out, right? So let's just say that I was bumping this up trying to look for output, and let's just say, I don't know, maybe I didn't see anything in the fluorescent right here, no arcs, but then I saw that needle move up a little bit. Well, at that point I might try to do what I just did and try to encourage a little bit of output, since I'm using some random caps here. I might try to see if maybe I can pull any type of baby arc, or if I could move this close enough to see if there was any type of noticeable field at all, right? If I wasn't able to do that, then what I'd probably assume is the phasing is all off, and I would need to essentially just reverse the polarity of my primary on the feedback over here. That'd be the easiest thing. And then I would try it again, right? So it just so happens that it's all set up right for feedback already. All right, so again, 15 volt seems about the bottom end with this specific tuning of where I can get arcs to come out. Obviously, I get them to go to the hand. So let's see. We'll put this at like, there goes 20 volts. See what that does. I'm gonna cut the lights down again. For some reason, it's not showing up on the phone right. All right. Got to get that started as well. And Let me do 24 about. It's interesting. I'm using a new phone. It actually looks like the frame rate is making it look like the arcs are pulsating in and out. So I'm not sure if it's actually going to show up like that in the video, but that's the first time I've ever seen that with a phone like that. All right, so essentially that's how this one's running with this random setup. So probably what I would do is I would run it like that, something like that for a little while, and I would start feeling on the temperatures of not only the this cap right here with the switches, as well as probably these guys down here, just to kind of see it's like, okay, are any of these things working too hard? And it doesn't feel like they actually are. So probably what I would do is, once again, I might kind of tweak around with the primary impedance a little bit. Probably another thing to do is I might, run it down to lower voltage to see what the continuous wave looks like. And again, probably what I'll do is, it doesn't look like I want to do it right now, because I will need to encourage some type of tuning to where it wants to kind of jump out to my hand a little bit more at the higher voltage. But I wouldn't really want to try to run this too long at 30 volts with these switches, right? Because I would feel like they might blow up. I would actually have to kind of pay attention to what I was doing with the tuning to be able to do that. But like I say, one way I feel like to kind of do that without really scoping it maybe is just play with these values here, primary impedance, maybe this cap value, the coupling, and see if you can get it to about 24 volts or so, to the point where it seems like it really does want to jump out to the hand quite a bit. And at that point you might be able to say, okay, well, maybe I can get a tuning where at 30 volts it's going to give me pretty good arcs, and then even when I draw my hand about to this distance, it's not going to detune it so much where it's either going to affect the circuit or make the arcs a little shorter or whatever. It might actually reach out a little bit further, to hit that hand to get an even longer arc, right? That's the best way I can put it. So I'll probably play around with this some more, and once again go through the same process to see if I can tweak this a little more. And then part of that is probably also going to include doing things like playing with this specific breakout point, the top load, the shape of it. That's why I've got like this little guy, things like that, right? And I might be able to tweak it a little better to where I get like what I would consider about as good as I can get, right? And I just remembered I was going to show this one a little better. This one right here would be an example of one that I thought was probably about as good as I could get with such a setup. And I've just got one video of it. I've got 2 turns on the primary, and I guess the video that I tried to show the internals in didn't really show up too well, but you can kind of see, I mean, it is the same thing. It's just the layout is a little different, right? And you can see there goes my feedback transformer right there. Just yet another dude that I grabbed. Now these FETs, I think I've listed them before. I might actually buy some more of those because these seem to work pretty good. Now these are 100 volt 55 amp FETs, right? SMDs, and I just pulled them from some board, and that's how it's set up. Seems to run pretty good, right? But once again, it's pretty much the same exact thing. I just really like this one. So I didn't want it to be confused that I actually thought the output on this one was so good. Some people might think like, okay, there's like a, there's like a boost circuit in here somewhere. But the point is, no, there's 30 volts. I've put 30 volts max on the rails, right? What that equates to is a positive and negative 30 volts for a higher peak to peak, but that's what it is. There's no like, switching circuit on here that's producing hundreds of volts or anything, right? So that, because if there was, I would just use like a half bridge or a full bridge build, right? So again, that was the point of this. That's this a little bit closer just to show, like, once again, like I've already just shown this circuit and the other two circuits. But you can see, there you go. There goes, I would imagine that's a 100 nanofarad capacitor that I've got in series with one of those primary legs. And down there, you can just barely see those are 6.8 nanofarad caps on the drain. So, there you go. Maybe I'll show this one again later at another point, but next I'll probably show what I end up with, when I try to tune this recent one I just made as good as I can get it. Then I might go over that a little more, right? But yeah, that's about it.